Source conversion is a very simple concept, but it's very important for circuit analysis. And before we go into conversion, we have to first know the difference between voltage source and current source. So let's start with voltage sources. In DC circuits, voltage sources usually look like this or like this. This is the positive, negative, positive, negative. Now what voltage sources do is they provide the voltage, and voltage by definition is the potential difference between 2 points in a circuit. Now what is electric potential? Electric potential is the amount of energy needed to transport any charge, any positive charge, from one point of a circuit to another point of a circuit. Let's say this is a part of a circuit, okay, and these are 2 points. So if we wanted to transport an electric charge from here to here, the energy needed would be called the potential, and that potential, the difference of that potential is the voltage that we get from these sources. Now it can be explained in a formula. It has the formula form, so like V is equal to W. V is equal to W over Q. So voltage is equal to W represents energy and Q represents charge. So energy over charge, that's V is equal to W over Q. And from this we can explain what 1 volt is. So 1 volt is basically the energy needed to transport 1 unit charge plus 1 coulomb from one point of a circuit to another point. That is what 1 volt is. The amount of energy needed to transport a unit positive charge from one point of a circuit to another point. Now there's also electromotive force, E. Electromotive force is pretty much the same as voltage, except for one thing, that for voltage it's from one point to another point, but for electromotive force it's from this one point back to the same point from the whole circuit. So if we have a circuit like this, okay, and we have a source here, then if you want the electromotive force, it's basically the energy needed to bring 1 unit charge from this any random point all the way through the circuit and back to that same random point. That is electromotive force. Now let's move on to current sources. In DC circuits, current sources look like this, an arrow in a circle. So the arrow can be pointed anyway, but that's it, arrow in a circle, that's the current source. And current sources provide current. And what is electric current? Electric current is the flow of charge per unit time. So I is equal to Q over T. Current is equal to charge per unit time, so flow of charge per unit time. That is electric current, and that's all you need to know about current sources in DC circuits. Now let's go to conversion. So what's the difference between voltage and current sources? Voltage sources provide voltage, current sources provide current. V is equal to W over Q, I is equal to Q over T, and that's pretty much it. Yeah. Now we'll know some more differences when it comes to conversion. So voltage sources, they always remain with a resistor in series connection with them. So voltage sources will always have a resistor like this connected in series, and the current sources always have a resistor connected in parallel to it. So that's another difference, in parallel. Okay. So let's put the polarity plus minus, and for current sources the polarity is where the arrow is pointing, that's plus, positive, and the other side is negative. Now voltage sources always remain in series with a resistor, and current sources always remain in parallel with a resistor. Now if we want to convert, let's say this voltage source is 6 volts and this resistor is 3 ohms. If we want to turn this into this, the first step is to redraw this. So we'll remove the voltage sources and draw a current source, and then we'll draw a resistor in parallel to that current source. That's step 1. Step 2 is to put the value of the resistor. So 3 ohm. It stays the same in different position, but same value. Next, we find the value of the current source. So it won't be 6, obviously, it'll be different. Now how do we find it? Using Ohm's law. I is equal to V over R. Now V is 6 volts over R 3 ohms, so we have 2 amperes. So this current source will be 2 amperes. That's it. We've done conversion between voltage source and current source. Now let's do it the other way. Current source to voltage source. Let's draw a current source with the same value we got there, so 2 amperes. And then the resistor in parallel. Okay. And resistor also same value, so let's keep it 3 ohms. Now we want to convert this to voltage source. Step 1 is to redraw, removing the current source and replacing it with the voltage source, and then the resistor in series. That is a very bad resistor, so yeah, much better. Now step 2, putting the value of the resistor same as before, so 3 ohms. Now step 3 is we calculate the voltage or the source of this the value of this voltage source. Again, by Ohm's law, I is equal to V over R. We rearrange that to V is equal to IR. For I, we have 2 amperes times R 3 ohms. So we have 6 volts. So our voltage source will be 6 volts. Again, same as here. So no matter which way you convert, the values will remain the same. 6 volt here will again turn out to be 6 volt here, and 2 amperes here will again turn out to be 2 amperes here if you redo the process. So that's all. It's a really simple concept.